So for this lesson, we are going to be taking a look at hooks. Hooks are special functions that let you use useState and other React features in functional components. And hooks allow you to use features like state and lifecycle methods in functional components, making them more powerful and easier to manage. In React, we have quite a number of hooks. We have a lot of hooks, but the two majorly used hooks, the two commonly used hooks are useState and useEffect. useState is used to manage states in functional components, and we can see this is an example of how useState is being declared in React. Let's get to our code editor and see how that works real quick. Okay, here in our app.jsx file, we can see useEffects and useState is being imported from React. Before we can make use of useState and useEffects in React, we have to import them this way, so we won't have any complications while building. And we can see over here how useState is being declared. The conventional way of writing useState in React is to name the state after the task you want to perform. In this case, it is count. We're trying to count the number of actions. We can also say toggle. Maybe you are trying to manage the state of how you toggle a button in your application. You can see toggle, set toggle. After naming the state, you come over here and say set the name. In this case, set count. This is count. This is set count. And we can see this state over here is storing a value of 0. And if we come down over here, we can see this button with an onClick function that is calling the set count function from the useState over here. It is calling this set count function, and it is passing the count name as a parameter. And what this does is it increments the count by 1. So anytime we click on this button, the value over here is going to increase by 1. And if we head over to our browser to see an action of that, we can see anytime we click on this button, the value is going to increase. That is the work of the useState for the useState hook in React. It is keeping track of the state of the number, so we can see it's increasing. And on the other hand, useEffect is used for side effects like fetching data, setting up subscriptions, or manually changing the DOM. So in React, this is how we declare a useState function. useEffect function in React. So everything we do inside this useEffect function is going to re-render every time we refresh the page. So an example of this is a weather application whereby you're trying to get the weather data of a particular location. When you put in the name of the location and you click enter, the data is being fetched from a source, and it is being displayed on the screen. And that happens every time you refresh the page, or there is a change in action on the page. And that is not really ideal, because it's going to slow down the performance of the application. So a way to fix that is by adding something we call a dependency array over here. This is a dependency array, and what this does is it prevents re-renders every time there is a change in action on the page, or the page is being refreshed. It prevents re-renders. So the code inside of this function re-renders only once and not multiple times. Another set of hooks I would like to show you guys is useCallback and useMemo. In React, there are hooks that they help in optimizing the performance by memorizing values and functions. They also prevent unnecessary renders or recalculations, which can be very costly in complex applications. useCallback returns a memorized version of a callback function that only changes if one of the dependencies has changed. So we can use the use callback hook when we have a function that is being passed as a prop to a child component, or that is being used as a dependency in a useEffect hook. useCallback also ensures that the function reference remains the same across re-renders unless there is a change of dependency. Bear in mind that while working with useCallback, we also have to import it this way in our components. We have to import it from React into our components. And if we take a look at this code in this component, we can see there is a child component here that is logging child component rendered on the console, and it is also returning a JSX button that says click me. We have a functional app component here that has a state, is a set count state, storing 0 as the value, and we can see there is an undo click function here that is incrementing the count value by 1 every time it is being clicked. And we can also see this functional app components. It's returning a JSX that is displaying the count every time it is being increased. So we can see useCallback here. Without useCallback, if undo click was declared, this undo click, if it was declared, it will be recreated every time the app re-renders, and this is going to cause the child components to re-render unnecessarily. So it's going to re-render the child components over here. It's going to keep re-rendering without the need, and that is not what we want, because it's going to obviously slow down the performance of our application. But with the use of callback hook here, the function is only recreated when count changes. Anytime this count changes, that is when the function is being recreated, and this helps to prevent the unnecessary renders of the child components, thereby improving the performance of the application. So for useMemo returns a memorized value, avoiding expensive calculations on every render. We use useMemo when we have a computation or calculation that is expensive in terms of performance, and we want to avoid recalculating it on every render. useMemo only recalculates the value when one of the dependencies change. Here is an example of how useMemo works in React. Also, do not forget, for every hook we work with in React, we have to import them from React over here. So if we take a look at this code over here, we can see useMemo here. Without useMemo here, the calculation, that is this count multiplied by 2, this calculation over here, it would run on every render, even if it is not necessary. For example, when the text changes, this text in this input field, when it changes, this would also re-render, and that is not like really good for the application, because the performance is is going to be slowed down. But with the use of useMemo here, the expensive calculation is only recalculated when count changes. Only when count changes here, that is when the calculation is going to run, and not when text changes. useMemo here will prevent unnecessary recalculations and also improve the performance of the code.